Hello all, welcome to part 24 of the Wireless LAN Security Mega Primer. In this video, we will look at how to speed up WPA and WPA2 PSK based cracking. So if you remember, in the entire process of the WPA or WPA2 PSK attack, uh, one of the most CPU consuming calculations was actually conversion of the passphrase to the pre-shared key or the PMK, right? And the simple reason was, well, this had to go through 4096 iterations before it would actually give us the 256-bit pre-shared key. And if you look at the next step, which is using the PMK and couple of other interesting variables like the S nonce, A nonce, AP MAC, and client MAC, this calculation with the PMK is actually very simple, and it does not take up much CPU cycles at all. And from there we derive the PTK, which we verify with the MIC. So what people figured out is that if we can somehow speed up this process, which is conversion of the passphrase with the help of the SSID as well into the PMK, which is the pre-shared key in this case, then we could actually go ahead and speed up WPA, WPA2, PSK cracking by leaps and bounds. And this is where there's an interesting concept called time memory trade-off. Now, what time memory trade-off actually says is that if some calculation can actually be done way ahead in advance, and that calculation can be reused all the time, then basically by using a lot of memory to store those calculations, we can bring down the overall time in actual practice when we want to do those calculations. Why? Simply because it is as easy as a lookup. So now imagine what we could do with this calculation. Can we speed it up somehow? Now, if we look at this further, this function requires the SSID. And if you think about it, well, we could generate a huge list of commonly used SSIDs. And a very good place for that is wiggle.net, where they've tabulated millions of SSIDs and actually ranked them by popularity. And at the very same time, the other input to this function is actually the passphrase itself, which can be fed from a dictionary. What this actually means is we can pre-calculate the PMK for a given SSID and for a list of passphrases from a dictionary. And hence, this huge calculation can all be done much beforehand. The most important thing to note is that the SSID is a very important part when you're making the PMK, which means if you have two access points, even with the same passphrase being used for PSK, if they have different SSIDs, the derived PMK with the PBKDF2 function will be totally different. This is a major point. So the other parameters, as you know, in creation of the PTK are pretty much in our control, in the sense it does not take too much time to calculate that. At the very same time, this is something which can never be pre-calculated and kept. Well, why? Because the AP nonce as well as the client nonce, both of them are actually going to be big and random all the time, and hence figuring out all possible values for them along with all possible MAC address, as you can clearly see, is an impossible task. And hence that is anyway something which cannot be pre-calculated. So what are we going to do now to speed up cracking? So as many of you have already guessed, instead of going through the painstaking approach of taking every passphrase, taking the SSID, having them go through the function to get the PMK, we will pre-calculate all the PMKs for a given SSID and for a list of passphrases. So here is the deal. Let's say you know that your target has an SSID D-Link, and you also suspect that probably they use a very common passphrase. what you would do is for this SSID, you would use a huge dictionary like the one on Backtrack or elsewhere, and then pre-calculate the PMK for every pair of SSID along with the passphrase. Now in this case, the SSID of course is stationary. But as you can imagine, we could have a list of SSIDs and a list of passphrases, and then you can have pairs. One SSID with all the passphrases, then the next one with all the passphrases, and create the pre-calculated PMKs and store them in some sort of a database. Now when you do this, now in the actual field, all you have to do is take those list of PMKs, take these values from the handshake, create the PTK, and then verify with the MIC. Whenever there is a match, it means you have the right PMK in place, which can be backtraced to the right passphrase. So hope this is clear. I think this just follows from the WPA PSK cracking, and I guess most of you already guessed that this is what would be the step, right? Okay, so there's a lot of interesting stuff around how fast can we crack WPA PSK using these pre-calculated PMKs, and tons of possibilities. You have multi-cores, you have the CUDA platforms. NVIDIA has tons of cards with so many CPUs on them, and very recently people have even started cracking this in the cloud by using things like Amazon EC2. However, I do not have any access to CUDA or any other hardware, so I'll run you through the process, but I really cannot crack hashes so fast. If any of you have access to such powerful hardwares, I'd really appreciate if you can make a video probably showing the whole hardware, running through the whole process, right? So I'll be doing a couple of demos, very basic ones, of how to pre-generate the PMKs, and one of the important tools I like to point out for this distributed very fast cracking is Pirate. And I think this diagram which I've pasted here is directly from their Google code page, where they are comparing the speed at which they can compute PMKs per second on various different hardware, right? So you have the GeForce, the Tesla and whatnot. I don't have access to all of these. I'm just a poor guy sitting in India. So if you have access, feel free to add some videos. I'll now take you through the process of generating the PMKs. So if you remember, previously what we used to do was we used to just use AirCrack directly and crack by providing it with a dictionary, right? So let's say this is the dictionary and this is the PCAP file we used in the last video, and we'll select the network and voila, it's cracked, right? But how do we now pre-generate all the PMKs and use it with various tools? So for that, there is an interesting utility called GenPMK created by Joshua Wright. And what we are going to do is we just have to give it a dictionary file, and as I mentioned earlier, an SSID, which is D-Link in our case, and an output file. So let's call it pre-computed PMKs. Now this dictionary file, if you remember from the previous video, just contains two entries, just to keep it simple for the time being. The QWERTY and then security tube. And let's go ahead and calculate these, and if you notice, it has calculated them, and the PMKs are now stored in the current file. Of course, I think it's not even printable, so you may actually get a lot of weird output. Along with, of course, if you can look at it, it's storing the access point SSID, it's storing the actual passphrase from the dictionary, and of course after that the computed PMK for that, right? Anyway, so now let's use this pre-computed PMK file with various tools. So the first tool we'll use is Copatty. Copatty can directly take input, and instead of the -F option for the dictionary file, we'll actually use the -d option for the pre-generated PMKs, right? So this is what it is. We know basically that the access point has an SSID D-link, and then we give it the file, capture file. I think this is with the -r option. And if you notice, it used the pre-computed PMK to go ahead and crack the passphrase, which was security tube. Now, how do we use this with other tools? So one of the other tools I'd like to mention is Pirate, as I showed in the slide previously. So Pirate is actually a very powerful tool as far as cracking WPA is concerned. And I'm only going to be touching at some very high level points. As I said, I don't have the hardware, and hence I really cannot have a lot of fun with many of these options. So if you have the hardware, show a demo. I'll take you through some basics of Pirate. One of the first things you can do before you even get started is actually analyze the trace file. And the trace file is fed with the -r option. And we then give the command called analyze. And this gives us a very beautiful text printout of the overall stats. And if you notice, it actually says that for one of the access points with ESSID D-link, it was able to find a handshake. This actually tells you that it's actually WPA2 PSK, and it has the handshake packets. So now what we can do is we'll actually use the attack_copatty to use the pre-generated PMK using GenPMK along with Pirate. So the option for an input file is -i. So let me give it the input file, -i WPA2 psk.cap, and then we have attack copatty. Oops, I actually had to give it the pre-computed PMKs. Instead okay. Right? Awesome. And if you notice, this was also able to tell us that the passphrase is security tube. So this is how you can actually create these long list of pre-computed PMKs with the help of GenPMK and other tools. There are tons of them. People have even distributed, like rainbow tables for these. Rainbow tables typically was used in the old MD5 hashing part, but people have created full tables for cracking WP and PSK by pre-computing all these PMKs for commonly used SSIDs and commonly used passphrases. I think you have the Church of Wi-Fi, which probably was the first to release these tables. Have a look. As I said, unfortunately, I'm not too excited about it because I don't have the hardware to enjoy that. So, but I'll leave that as an exercise to you. This is all there is to it. Before I end, very quickly, how about our favorite tool, AirCrackNG? Now, if you notice, it does not seem to have an option anywhere to take in a copatty or a PMK file directly. However, there is an interesting option here called -r, and it says path to aerolib-ng database. So let's look at what aerolib-ng is. And this can be used to create the PMK based database which we were talking about. Actually, aerolib-ng itself could be a separate tutorial, but the tool usage is quite simple. You can import SSID lists, you can import passphrases, you can import PMKs directly from copatty and whatnot. I leave this as an exercise to you because, as I said, there is nothing much to it. You can go to their website, look at the explanation page. It's quite detailed. What I will do is I'll just quickly import the copatty pre-generated PMK file which we created using GenPMK. So first we'll give it a database name. Let's say PMK hyphen aerolib, and then after that the operation in our case is just going to be a simple import of the genpmk file which we created. Right, awesome. So it's created the database file, and you can look at it here. This is the database file which is created. This is actually an SQLite DB file. So people who are aware of SQLite can even directly just go here and kind of figure out everything on this. Right? So you could do a lot of interesting things by looking at the different tables, by going ahead and dumping things here. So this is where you have that. You could have the list of ESS IDs, which is D-Link, have the list of passwords and whatnot, right? So I leave exploring this to you. I'm not really going to get into the details of SQLite and all that. So the point, what I want you to notice, this is actually an SQLite file, right, which is created. Now, this is where aircrack-ng comes into picture, where we can actually give the SQLite file we just created and whose name I have comfortably forgotten, pmk-aerolib, pmk-aerolib, and along with that, I have to give it the pcap file to crack. It'll ask me, and if you notice, awesome. So now we are able to use aircrack-ng with the pre-generated PMK file. Let's go back to our presentation. I guess that brings us to the end of, how do we speed up WPA2 PSK cracking. The basic idea is to pre-compute the PMKs based on a list of SSIDs as well as a list of passphrases from a dictionary file. And then the next process of verifying that using the MIC from the four-way handshake by deriving the PTK and applying to it is very trivial, very fast. And because we've brought down the amount of time required to actually calculate the PTK using these pre-computed PMKs based on the time memory trade-off principle, we are able to speed up the cracking of WPA PSK. I think a couple of 100,000 times maybe, right, depending on the hardware you're talking about. Well, that's it for this video. Hope you enjoyed it. Please leave your comments behind. As always, I'm very excited to read your comments, and see you again in another video. The funny thing is, stopping the recording